Okay, Houston, we've had a problem here.
This is Houston. Say again, please.
Houston, we've had a problem.
Houston, we don't have a problem. Today we're going to talk some more about acceleration and acceleration vectors, how they work, super important. So acceleration can get confusing for a lot of you. So let's just make sure we understand the concept of acceleration. Now, we learned in the last video, or the last couple of videos, that you have velocity, which is position or distance divided by time. All right? And acceleration is actually velocity divided by time. Now, the idea of acceleration is that let's go back. In the last case, if you recall, we had a situation where the velocity was constant. Somebody's traveling, I forget what our number was, at 20 miles per hour consistently. So you're driving down the road and you're moving at 20 miles per hour and you keep going at 20 miles per hour. That's called constant velocity. But when you are at a stop sign, you're going 0 meters per second. So let's say you're at a stop sign, boom, you're here, and this is distance versus time, and you're starting at 0 distance. But if you're starting there, what you actually do, and you know this when you push your accelerometer, you push your pedal on your car, you start to accelerate, you start getting faster and faster and faster and faster. And that's called acceleration. And what it turns out is when we graph acceleration, we'll talk about this in the next video, you see a graph that looks parabolic. It is parabolic. And you get acceleration. It's getting faster and faster and faster and faster. A way to sort of illustrate this is, let's think about this. So the definition of acceleration, let's say def, is the change in velocity. And let's talk about the units. If velocity is meters per second, it's meters per second divided by seconds, or you could say meters per second, or we usually just write meters per second squared. So that means when you are traveling, actually let's go to the next slide here. That means is that if you've got a car like the one we've got right here, it starts at rest, and after 1 second, it's traveled 3 meters. After 2 seconds, it's traveled 6. Actually, it's traveled 9 meters, but 6 more, right? And after 1 more second, at the 3rd second, it's gone 9. So it's getting faster by 3 meters per second every second. Does that make sense? So acceleration is getting faster and faster and faster, right? Changing your acceleration by going faster. If you drop something, we'll talk about this in a lot of cases, but if I were to take my pen right here, make sure you use the pen, and I drop it, at first it's going 0 meters per second, and then as I drop it, it starts to get faster and faster and faster and faster. And if I was on the top of a tall skyscraper, it would get, scraper, it would get faster and faster and faster and faster as it fell. But that behooves, guess what? You can have a negative acceleration. Acceleration is a vector, and what does it mean when you have a negative acceleration? Well, let's look at this picture. Hopefully this is going to make sense. We got a car who's traveling at 20 meters per second at time t equal to 0. And then we move over here to 1 second. It's now going 18 meters per second. 1 second later, at 2 seconds, it's going 16 meters per second. And at 3 seconds, it's going 14 meters per second. So what's happening to this car? It's decelerating. So decelerate, this is putting your brakes on, or you're coming to a stop sign, you put on your brakes. So deceleration is like negative, right? And in this particular example on the board, what would be the acceleration? You notice that every second it gets 2 meters per second slower. Maybe you can figure this out. It's going to be what? Yeah, negative 2 meters per second squared. Because even though they're moving to the right, it is decelerating. Now, to make it even more confusing, what if I have this situation? All right, there's more than one way to do deceleration. We think of acceleration in the positive direction. The positive direction is going to be left to right. All right, so This is the positive direction. So if I am moving in this direction and I'm accelerating, it's positive acceleration. If I'm putting the brakes on, so to speak, or slowing down, it's negative acceleration. But if the car, in this case, is moving in the negative direction, if the velocity is in the negative direction, we learned about that, okay, and they're getting faster, the acceleration is in the opposite direction. Okay, if you're decelerating. Sorry, they're putting in figure C, they're putting the brakes on, so they're slowing down in a absolute sense velocity, but that makes the acceleration to the right. And in picture D, they are increasing their speed, right? They're accelerating. In this case, as they accelerate, then the acceleration is negative even though they're getting faster because they're moving in the negative direction. Watch that. On some of the questions on the problems, it's all about thinking through these signs. You'll see these on some of the test questions, et cetera, too, is you can get your brain all backwards. But this graph, I would highly encourage you to sketch this thing. This will help you way. Houston, we don't have a problem.